Well, we're back dealing with log equations. Let's pick up with another example. We have log 5x minus 5 equals negative 3. The first thing you may notice is that there's no number here by the g in the log. Well, whenever there's no number there, it's understood that there's a base 10 because logarithms are built on a base 10 exponent. So we can be saying log base 10 5x minus 5 equals negative 3. So let's isolate our base. We'll add 5 to both sides. Now we have log 5x equals 2. Now we can use the circle method to convert our log to an exponential equation. And when we do that, now we have 5x equals 10 squared. Where'd the 10 come from? Remember, when there's no number here, it's understood to be a base of 10. So we take our base, and now we have it here for a 10. We take our number here, and it becomes our exponent, and our product still remains 5x. So 10 squared, ladies and gentlemen, gives us 100. So now we have 5x equals 100. To isolate my x, we can divide both sides by 5, and x equals 20. Now if we were to check that, all we would do is take this 20 and plug it back in here for x. Well, log base 10 of 100. Log base 10, 5 times 20 is 100. So you can plug it in and it works every time. Let's look at our next equation. 5 plus 2 natural log x equals 4. 5 plus 2 natural log x equals 4. Subtract 5 from both sides. Now we have 2 natural log x equals negative 1. Now we can divide both sides by 2. And now we have natural log of x equals negative 1/2. Now, to get rid of this natural log x, remember, we can put in an e, base e here, and that'll cancel both of them out. So put a base e here and base e here, and now when these cancel out, we have x equals e to the negative 1/2 power. Log of x equals, log of x plus log x plus 3 equals 1. So remember when we're condensing logs, we have to condense this log first because of this addition sign right here. We know that we'll be going using the product property, so we make these two logs products. So now we have log x times x plus 3 equals 1. Remember, understood base 10 here, so we can convert this to an exponential equation. And now, using our circle method, we have x times x plus 3 equals 10 to the first power, or it's just 10. Well, let's distribute over here. X times x is x squared. X times 3 is 3x. So now we have x squared plus 3x equals 10. Now, how can I solve for x here? Well, I know that because I have x squared here, I'm dealing with a quadratic equation. So the first thing I got to do, subtract 10 from both sides. Now I have x squared plus 3x minus 10 equals 0. Now we get to factor, because when you have a quadratic, you have to solve it by factoring. Well, I can look at my quadratic and say, negative 10 and a 3. What are my products of negative 10 that when I add them together give me 3? Well, I know that 5 and 2, when I subtract them, gives me 3, so let's use those numbers. We have 5 and 2 here. Now I got to add them together to give me a positive 3. Well, the only way that happens is if I use a positive 5 and a negative 2. Now I know I have to do something like that because of this minus sign right here. This minus sign tells me I got different signs in my factors, and this positive right here in front of the 3x tells me that my biggest number will have to be positive. So x plus 5, x minus 2 equals 0. I set each one equal to 0 and I solve them. And when I do that, I have x equals -5 and x equals 2. Now, if I try to check these, the first thing that jumps out at me is this -5. I can't take the log of a negative number. So I can't take the log of a negative number. I know that's automatically going to cancel out. And x equals 2 is my answer. Let's look at another example, shall we? Log of x minus x plus 3 equals 1. Now, looking at this, I automatically know that this is a subtraction sign here. So when I condense them, I'm using my quotient property. So I condense it down to log of x over x plus 3 equals 1. Now, I can circle method this thing out. And when I circle method it out with a base of 10, I now know that x over x plus 3 equals 10. Well, how did you get that? Well, because there's no number here small, I know that I'm dealing with a base 10, so that I'm dealing with log base 10. So if I had base 10, I do base 10 on this side and base 10 on this side. My base 10 on this side cancels out my log and leave me with x over x plus 3. My base of 10 on this side, 10 becomes my base, 1 becomes my exponent, and 10 to the first gives me 10. Now I got to solve this. So as I'm solving it, I'm solving a fraction, so I know I got to multiply both sides by x plus 3. When I do that, this cancels out on this side and leave me with just x. So now I have x on this side. I multiply x plus 3 on this side. Now I have 10 times x plus 3. Let's move over here and give me some room. Using my distributive property, I now have x equals 10x plus 30. Well, how'd you get that? Well, 10 times x gave me 10x. 10 times 3 gave me 30. So let's continue solving this, shall we? I got to isolate what I don't know. So I'm going to subtract 10x from both sides. Now I have negative 9x equals 30. Negative 9x equals 30. I divide both sides by 9. I have x equals negative 3.33. And just like from last time, I can't take the log of a negative number. So since that's my only thing I got here, I know that I really don't have an answer here. So my answer here is no solution. I hope this kind of helped you out here. Hope you can see this. Now let's look at our last one. We have e to the 2x power minus 4e to the x power minus 5. Now some people suggest doing it the long way. I just say we factor this thing out because I know that e to the x times e to the x gives me e2x. So if we factor this, I know that I have e to the x and e to the x. Now what are my factors of 5 that can give me 4? Well, I know that I have 5 minus 1 gives me 4, but that's positive. I need to get a negative 4. So now I can say negative 5 plus 1 gives me 4. So when I factor this out, I have e to the x minus 5 and e to the x plus 1 equals 0. Now, if you needed time to think about this, ask the teacher to hit pause. Well, I guess you're still with me. So, first thing we did was we factored this equation. Now, we set our factors equal to 0. E to the x minus 5 equals 0. E to the x plus 1 equals 0. Over here, we can add 5 to both sides. E to the x equals 5. We apply our natural log. Our natural log cancels out this e right here. So x would be natural log of 5. What about this side? Subtract 1 from both sides. Now I got to get rid of this e, so I apply my natural log. When I do that, this cancels out over here to leave me with just x. And I have natural log of negative 1. I can't take the natural log of a negative number. It's not possible. So my only solution here is that. You should have a worksheet in front of you now. If you don't, be quiet and sit quietly. It's on its way. Hope this helps. If not, feel free to drop me a line on Edmodo, or you can even email me. I'll try to get you an answer as soon as possible. Have a great one.